Hello everyone, welcome back to my YouTube channel. So on day 8 of Kubernetes series, today we are going to focus on DaemonSets. So DaemonSet is a Kubernetes controller. It's a similar to we have like a deployment controller and we have replica set controller. So similarly we have DaemonSet controller. As we know, each controller has their own jobs. So let's understand what is DaemonSet in this particular video. So let's imagine your Kubernetes cluster is like a big office building with many floors, and here we are representing each floor as a node. So now normally when we deploy our application on Kubernetes, we use generally deployment manifest files, and Kubernetes makes sure we have right number of pods up and running, but it doesn't care where they run, just the total number of count. Like they can schedule on single node all the two pods, or maybe in two nodes it can schedule. So like we are not sure where basically they are running, but suppose if we want to run a pod on each node, then we have to use a daemon sets. So like it's similar, we have like in corporates, each floor we have one front office guy. So similar concept here we have with daemon sets. If we want to deploy a pod on each node, in that case we should use a daemon sets. So let's see some real world use cases where we should use a daemon sets. So daemon sets are perfect for node level service because Kubernetes makes sure if you are using a daemon sets, then always you will have a one pod on each node. So generally we use daemon sets for logging purpose, like log collectors, monitoring agents, network plugins, security tools. So on these places, for these particular things, we can use our daemon sets, because we need, suppose if I'm going to use log collectors, like I need to collect the logs at node level, then any agent should be available on that particular node, then only we can collect the informations. So daemon sets make sure a pod run on each node. Like if we have three nodes, then three pods will be run on each nodes. So we will get the logs or the data or the information which we require at node level. So we can easily collect it. So generally daemon sets are basically perfect for node level services. Similar concept here we have with monitoring agent, network plugins, security tools. So these are the use cases where we can use daemon sets. So here the key idea is these services basically needs direct access to node level data or functionality. Okay, now let's see how daemon sets works basically. So we generally define a daemon sets in ML file, just like our deployment manifest file, and the daemon sets controller constantly watch your cluster. So like obviously it is getting a response from API server. So as soon as it find out, okay, we got a new file with daemon sets, then it will, so basically what it does, so it will automatically schedule a pod from a daemon sets on the node. So if we have running 5 nodes, then it will schedule all 5 pods in each nodes. So one pod, one node basically, in simple words. So here basically we cannot use a replica set with daemon sets because they have a different use cases itself. Replica sets generally we use for identical pods. We just need a identical pod, that's all. But in the case of daemon sets, we need to collect node level information. So each pod or each agent should be available at node level. So here I have also mentioned you don't need to set a replica count. The number of pods is equal to the number of nodes. So if we have 2 nodes, then it will schedule 2 pods. If we have 3 nodes, it will schedule 3 pods. So you can even target only a specific node using a label or node selector. Suppose if you have thousands of nodes and you want to select, or maybe you want to run the logging agent or maybe monitoring agent on any 4 or 5 nodes, then we have an option, we can select those nodes using labels and node selectors. Okay, so now let's see quick comparison between a daemon sets versus deployment. So daemons deployment can run on any node, like basically it choose randomly. But in the case of daemon sets, it run on every node or maybe a selected node. If we are going to use our labels or selectors, in case if we have hundred or thousands of nodes, then we want only specific nodes to monitor. In that case, we can use labels and selectors as well. Pod counts. So here the deployment we have fixed replica, like whatever the number we have defined in manifest files, only those number of pods will be available. But in the case of daemon sets, the concept is one pod, one node. Use cases. So deployment generally we use for our web applications, APIs, and daemon sets generally used for monitoring and logging purpose. Placement logic anywhere in the cluster, but in daemon sets exactly one per node. So this is the major difference between a deployment and daemon sets. Okay, now let's move to a demonstration part. So let me go to my GitHub repository. So here is a folder called day8. Okay, so under this folder we have a very simple DaemonSets.ml file. So let me open it. And let me do first one thing. First, let me create a file in our local system. Then I will explain this file. So let me copy the name first and let me copy the content as well. Okay. Now let me save it. So if you see, this is the API version which is app/b1. So this is the API which we are going to use. REST API basically which we are going to use to create this object. So here we are going to create a daemon set. So that's why the kind is daemon sets. And under metadata, this is the name of this daemon sets, which is node info collector. And this is the label. And under specifications, again we have a selectors and match labels. And this is the match label which we are going to use here, app colon node info collector, which should be same basically. And under template sections, this is the part of our container. So here basically we are going to use a very simple image which is bgbox. So here basically we will get a basic Linux distribution with a bash shell, so we can execute a command here. And this is the simple argument which I have passed. So in every 5 seconds it will go and print hello from node. It should not be node, like you can print a node name as well. Let me change it to a pod, because we have specified we are going to run inside a pod. So in every 5 seconds basically it will go and print this message. So once we will deploy this this manifest files, and when we will go to logs of our pod, then we will see this message. So this is the command which we are going to pass. Why I am running this particular command in the daemon sets example demonstration, because I am going to use a Docker desktop, and by default we have only one worker node in Docker desktop. So we cannot see a real-time demonstration on Docker desktop itself. For that, definitely we have to use any maybe a cloud provider hosted Kubernetes cluster. So at least we will have 2-3 worker nodes, and we will see the demonstration of daemon sets. But it's fine as of now, as we don't have that cluster, so we are focusing on Docker desktop itself. So as we know, daemon sets basically deploy our pod on single node, or maybe not single node, one pod, one node. So let me do one thing. Let me save this file. So apart from that, and here also we have, I forget one thing, so termination grace period, so which is 5 seconds. So it basically allow for 5 seconds to shut down gracefully, or deletion or node or drain maybe. So like every 5 seconds, why we are mentioned here, because if suppose forget about this sample file which we are going to use, suppose in real time we are going to use any monitoring agent or maybe any logging agent, in that case we need to collect all the informations second by second. So in the case of troubleshootings, we will have complete information. That's why we are putting here like every 5 seconds print this message. So this is something I want to make a similar in a real world. So like every 5 seconds our any monitoring agent or maybe any logging agent collect the information. So same thing we are going to replicate here as well. So now let me apply this file kubectl apply -f and file name, which is nodeinfo demonsets.ml file. Okay, so the application pod is created basically. So if I clear the screen and I will go for kubectl get pods, so we can see a pod status which is running and 1 out of 1 also. Now let me copy the pod name and let's verify the log first. Kubectl logs and sorry s and the pod name. Okay, so I missed L here. Let me correct it. Okay, so here we can see a message hello from pod. This is the name of our daemon set which we have defined, and this is the date and time we are receiving. So this is the every 5 seconds basically it's going to print this message. Now let's verify the node itself, like how many nodes we have. As I told you, we have only single node. So if I clear the screen, kubectl get nodes. Oh, again I missed the command. Okay, let me correct it. Kubectl get nodes. So we have one node which name is Docker desktop, and status we can see, and roles also like control plane. Now if I'll go to my kubectl get pods command and if I'll go -o wide, so here we can see like this is the name of our pod which is running on this worker node Docker desktop, because we have only one worker node, and we can see the status of our pod as well, which is running on this node. If I will delete this pod and I will reapply it, then again we will get a new pod with a different name, but only single pod we can deploy with same kind on single node basically. So that's the purpose of daemon sets. We deploy one pod, one node, and we generally use daemon sets for our monitoring, logging, or maybe any other purpose as well, like based on the requirements. So I hope it's clear. In case if you have any doubts, you can ping me over comments box. I will keep the link of GitHub repo in description box. So if you want to do hands-on with your own you can do that as well. So see you next video. Thank you so much.